just before Christmas, I bought myself a AMG 8833 infrared array sensor, grid eye. I'll show you the specs for it, but I wanted some way of testing something that me and everyone have been working on for the CTI. I'll explain why it's so exciting, and then we're going to look at some code and we're going to look at it working. So the device itself is not mega exciting. It's a 8x8 thermal array sensor, so a thermal camera, and I paid £12 for it from Aliexpress, so it was very much a cheap piece of equipment, but it demonstrates the reading I2C. So on this camera you can just see my setup where I've sellotaped it to the front of my screen, mainly so I can stick my thumb on it and wave. So let's turn the camera back. So yeah, it's I2C, and the new drivers for CTI, so the latest version that we're testing, has access via the Pico to UART's I2C and SPI. So I'm testing the I2C at the moment. So we've got it writing to LCD screens, which works very nicely. Unfortunately, it doesn't on camera on mine LCD because it's got a very bright backlight and I can't turn it off. But I'm getting a new one, and I'll be talking about that, and I'll also be breaking down the I2C protocol a bit because I've learnt a few lessons which are worth passing on. Yeah, so there's lots of resources on this, but it's all again very you download a library and it works type resources, and I'd rather go a bit deeper. So here's the how you get through the protocol. Really, there's a manual. There's a Panasonic chip essentially. There's a manual. You're putting data or reading data from registers. So it's just a register. So the process is you give it a register. You either read or write that data from that register, and that data, 8 bits of it, means something. So I've gone through, and I haven't added all functionality. I've only really added enough to get us going, but the library's there to be improved upon. So let's have a look at it, shall we? So here's the code. So I've made it a bit posh, but we're going to dig around inside it because it's actually a bit more interesting inside. So if you just wanted to load the driver, this is all you need to do. So you just initialize the chip. You initialize the I2C on the Pico, you initialize the chip, and away you go. So let's have it running. And it's an 8x8 thermal array, so stuck to my thing. So it's used to detect humans. So you can see me moving. You can see me waving there. And you can see if I stick my thumb on the screen, it goes very hot because I've got a hot thumb. And then goes off. It was actually going nicely above 255. I was having issues with that. So you see that going white there. That's because I've set the intensity graph. So let's do that again. See if I can get it to go white. It tops out pretty much near 225. There we go. See, it flickers. But anyway, that's nice. It's good enough. Yeah, so we're getting an array of data out. So if we have a look at it, so the version of the Visa overlay on the Pico, so the UF2, is this, and that will be our new CTI standard. But let's dig into it and actually look at how the Visa has been done, because I think Derrick's done a very good job. So essentially this is the initialize. It's standard sort of sets up the Visa. to do I2C, initializes the VISA, tells it what pins, what GPI pin, IO pins it's going to talk out of, the baud rate and the bus, because you can have two buses, so you can assign different pins to different buses. Then I just ask, I'm very keen on getting the version out, just so I know I've loaded something correctly, so that just does a standard IDN, hello VISA, who are you? Then it goes on, and you have to set up the pull-up resistors for this. It seems to work a lot better. I've not actually tried messing around with them, but that was what I heard. I've not actually tested that myself, but there's your command, digital pin pull. So you pull up, pull down. We've got pull up, pull down, pull both. And it stores in the class data is the address and the bus, so you can run a couple of these off one Pico. So then we just do the initial setup. So we'll have a look at one, but then we'll look at the read. So we'll look at one right. It's much of a muchness really. So here we're actually let's tidy that up while I'm here. Boop. We're setting it to normal mode. Essentially, we're setting it to 0 to just work normally. Or because of power requirements, you can set these things to sleep until they get an interrupt and wake up. So they're quite natty little things. So here we're just setting data to the I2C bus. So we're setting it to register 0 and normal. So if we look at the file, just so that you understand the process, register 0. Is that one, I think? Yeah, register address 0, and 0 is normal mode. That's very sensible. All makes sense. So let's dig a bit deeper and get back into the just to show how clever this is. So the command is com. We tell the com type. You tell it this is the bus. You tell it what data you're sending, and then you format the data. And there you go. It's done for you. So maybe in me, I just dug straight in and started doing raw data, chucking bytes out and reading bytes on a scope. So the next video I do will probably be reading back the bytes from the scope from this. This is how I've been fault finding and evaluating it. So the next thing we do is, let's have a look at the image read. You can see here, this took a lot of digging out. It's a 10-bit return signal. Starts at 80, they say, but if you start at 7E, it seems to work. So I've started at 7E, and then give myself 2 characters, and then you just build it, and then you build it into a 2D array essentially. It seems to work fine. 10 frames per second is the fastest it will go. You can have 1 frame per second. There's other things like interrupts, and so these are used to detect humans, so the shape of a human. So you can actually set them to if an average or a shape is recognised, or some known factor. It's not a shape actually. If it's an average temperature is seen in front of it, it will set an interrupt off, and it will fire off a little GPIO pin on the out here, so you can detect that on your own, on the Raspberry, on the Pico. So that's all very, very cool indeed. And yeah, and this is it doing its thing. Very, very nice work. I would have connected the scope up, but the thing with I2C is if you start hanging too many things off it goes wrong. So what we will do is we'll have a look at the LCD stuff later. Do you see that as it goes over? It seems to get itself the ump. I think it goes into overload mode or something. But anyway, still bits to learn on this, but it's actually a nice example. See, it's picking up my hand movement there. But So, you know, we could go on and get bigger arrays of, but they're very expensive. You know, you can pay $50 for an array with more resolution, which for my thinking is not particularly useful. Oh, the thermistor value is working. It's interesting. I just lashed that together and I didn't retest it. Should we run it a few times and see if we can get a reading out of it? Bear with. It never works. Never works. Right. Okay. Don't know, let's take a reading every 100 milliseconds. And see how that goes. Obviously what I was going to do is just stick my thumb on it and see if it picks up any data. I haven't had this working yet. I wasn't that interested in it, so I gave up. But mainly I was testing the reading, because we've been testing so far on LCDs, which is all writing really. So, button on that, stick my thumb on that. It's doing something, don't know what it's doing. Interesting. It's one of those things, it looks vaguely right, but not quite right. Now we're back. But anyway, so why this is useful and why I think this is interesting from a teaching perspective and a hobbyist perspective and a maker perspective is that these devices are very, very low cost. And we're doing some funky stuff now, you know, and you can get A to D converters and all sorts of highly accurate chips that all work from I2C. So it opens up a world of things to play with. I'm looking currently at a GPS module, and there's just all sorts of things that you can bung on this, and it just opens up the world. So we're getting to a point, I think we might start trying to build out a device library of some description, just because I think it's very good. I was missing a lot of information, and when you dive into sort of the Python and Arduino type training materials, it really is very light on the stuff that you have to write, and it's very heavy on installing libraries, which for me, I want to get down to the bytes. I want to know what's going to the chip. So it was addressing that really. How do you make a driver that can tell you what it's doing? And yeah, and we're still going with that. But now you've got a Pico for however many dollars Picos are, $5, Visa overlay, and it can talk to instruments, it can talk to chips, it can do stuff. So it's a long way forward. This is a big advance from our first version of the Visa overlay, and it's working very well. I'm very happy with it indeed. So anyway, thank you.